Shobharani from Department of Computer Science in Chaitanya Deemed University. Today I would like to discuss about UML. UML stands for Unified Modeling Language. Unified Modeling Language. So here you can see the modeling. Here unified modeling language is used to model the software applications. Here by using YAML, we can able to model the software applications. Not only software applications, we can also model non-software things. Here YAML is providing a graphical notations. These notations are used for visualizing, specifying, constructing, and documenting artifacts of software intensive system. So here we are using YAML to model the software applications for visualizing, specifying, constructing and documenting artifacts of software intensive system. Why? Because if you develop the models, we can easily visualize our system. Even we can specify the structure and behavior of our software applications, and with the help of the models, the developer can easily write the code. They can easily construct the code for software applications, and after developing the software applications, what are the decisions we have made, we can document those decisions for that software application. YAML is also providing a standard way for writing software blueprints. So it is providing a standard way for writing software blueprints. So by writing the software blueprints for software applications, we can see the structure of our software application. We can form the conceptual things like business processes, and system functionalities, and we can also form concrete things like classes, database schemas, and other software reusable components. So by using the standard way of YAML, we can even develop the structure for the software applications and how the business will function. That is also helpful by seeing the models, and we can tell the functionalities of software applications, and we can also tell the concrete things like classes, database schemas and software reusable components. Now we will see what is model. Here model is simplification of reality. That means what we are going to construct, that can be simplified by drawing the models. Here, why we need models? Models help us to better understand the system what we are developing. For example, so if you want to construct a house, first we will go to the engineer and we will get a plan. So by using that plan, we can start constructing our house. So now with the help of plan only, we are constructing the house. For example, without plan, suppose if I want to construct a dog house. Okay, dog house. So I will just get the tools like pail of lumber and nails and some tape to measure and some cardboard, and I will get those tools, and with a little prior planning I will start constructing the dog house. And within a few hours I'll end up building the dog house. If as long as that dog house is convenient for the dog and if there is no leakage, the dog will be happy. But if we want to construct a house, so that house can be used by our family members. Here, family members will have more choices than dog. But if you start constructing, if you start building that house, we cannot start by simply taking some tools like nails or some material what we require for developing, for building the house. That is not enough without plan. Why? Because we are wasting after constructing our house, if we don't like that house, we will be wasting the time and we will wasting the money also. So with the help of the model, we can see that model and how the house it is going to be after constructing that. Okay, if we don't like that model, you can even make the changes in that model. For example, after seeing the model, you will get one idea how many rooms are going to be there in our house and which room will be located at which part of the house. And if you don't like that model, you can even make the changes in the plan so that we are not going to waste the money and we are not going to waste the time. So here models are proven in well accepted. Models are well accepted technique in engineering disciplines. Okay, here through the models we can achieve 4 aims. So, through the model, we can achieve 4 aims. First one is, models help us to visualize the system as it is or as we want it to be. So, we can visualize the system after constructing the system, how it is going to be. We can visualize those system with the help of the model. And we can specify structure and behavior of the system. You can also specify what is the software application and what is the structure of that application and how it will behave after developing that software application. Who are the users and how they are going to use that system. That is the thing we can see with the models. And next, we can construct. By seeing the models, the developer can easily write the code. He can easily construct the software application, and the models will provide one template. The template will guide us step-by-step procedure how we can develop the software application. So here these models are help us, the developers, to write the code very quickly. And next one, document. Models will help us to document the decisions what we have made while developing the software applications. So through the models we can achieve these 4 aims. Now we can see the principles of modeling. Now, principles of modeling. Modeling has proven well accepted technique in engineering disciplines. So the experiences suggest that there are 4 basic principles of modeling. First principle, the choice of what models to create has profound influence on how a problem is attacked and how a solution is shaped. That means while choosing the model, you have to choose the right models. If you choose the wrong models, it will misguide you. It will end up with the wrong product, wrong software application. Okay, so if you the choice of model what you will choose that will affect your software application will get correctly. Otherwise, if you are choosing the wrong models, that means you will end up with the wrong thing. The first thing you have to remember is that choosing of models is very important. Second one, every model may be best expressed at different levels of precision. For example, some models will consist of overall structure and some models will consist of detailed structure. For example, if you take the engineer's plan, suppose the engineer has built high-rise. He has given the plan for high-rise buildings. In that, you can see how many floors are there and in each floor how many apartments are there. Only that overall structure you can see in that high-rise plan. But in the detailed view, if you see the detailed view plan, in that in each floor, how many apartments are there? In each apartment, how many apartments are facing north and how many apartments are facing south? And in each apartment, how many rooms are there? And where you can see where is the living room and where is the balcony is there? That thing you can easily view easily. Okay, so that's why every model may be best expressed at different levels of precision. And then that means you are giving detailed view, or some models are giving detailed view, or some models are giving overall view. So every model may be best expressed at different levels of precision. According to the software application, you have to choose your models. Whether you want the overall view or whether you want to detailed view of the model. That thing you can choose. That is the second principle given by the engineers. And third principle. Third principle, best models are connected to reality. Fourth principle, no single model is sufficient. Every non-trivial system best expressed through independent set of models. Here, third principle, best models are connected to reality. So, model is a simplification of reality. That means while developing the models, we should not hide the important details. If you hide the details, you will end up with the wrong product. So, third thing, you have to create the models that should be connected to the real world. That means the problems can be solved by choosing those kind of models. So, that is the third principle. And fourth principle, no single model is sufficient. Every non-trivial system is best expressed through independent set of models. For example, if you are constructing the house, here not only choosing the building plan or house plan is not enough. So we need to choose the plans for electricity as well as plumbing, some elevation plans, and we need some other plans. All those plans are interconnected, then only we will end up with the final product. That means we will end up with a nice house. So that is the fourth point. Here these are the four basic principles of modeling. First principle, you have to choose the models well, then only you will develop the correct software application. And second principle, every model should be best expressed at different levels of precision. Okay, that means you can even construct the models, you can develop the models in detailed way or in overall view also you can give the models for software applications. And third point, best models are connected to reality. That means you have to give you should not hide the details, important details. So you should include each and every detail in your models. And fourth one, whenever you want to construct any product, one single model is not enough. You have to choose the interdependent models which are required for developing a software applications. Okay, these are the four important principles of modeling. Now, in software, there are several ways to approach a model. Here, we are going to explain two models that can be two approaches that can be used to develop a software models. First one is algorithmic perspective and second one is object-oriented perspective. First, the old method is algorithmic perspective. In olden days, the old method is algorithmic perspective. In this algorithmic perspective, the main building block is function or procedure. If we use algorithmic perspective to develop a software models, we will mainly concentrate on functions and procedures. But most modern contemporary language programming languages are nowadays object-oriented. So, second approach is object-oriented way. So, object-oriented approach. In this object-oriented approach, we will concentrate on classes or objects. See, if you see the system in object-oriented way, you will end up with the classes and objects. So, nowadays all programming languages are supporting the OOPS concepts. Our UML is also a graphical language to develop the models for object-oriented programming languages. So, these are the two ways. Old method is using algorithmic perspective to develop the models and contemporary way, modern way is object-oriented perspective. By using the, we will here in this, we will be concentrating on classes or objects. Now, conceptual model of UML. If you want to understand the UML, you need to learn the conceptual model of UML language. This conceptual model is consisting of three key elements. First one is building blocks, second one is rules, and third one is common mechanisms. So, if you gain experience in three key elements, then you can able to form the conceptual model of UML. First one is UML's building blocks. You have to learn first key element to develop a models for software applications. Why? Because UML is a graphical language. It is providing us some graphical notations. By using that notations, we can draw the models for software applications. So these building blocks will provide the graphical notations and how you have to use that graphical notations to create the models. And second one is rules. These rules will dictate how those building blocks should put together. And third one is common mechanisms. These common mechanisms will help us, guide us how those rules can be applied throughout the UML. Once you are familiar, once you gain experience in three key elements, these three key elements, then you can able to form the conceptual model of UML. So by learning these three key elements, you can able to create models for software application and you can able to read the models somebody has developed. So this is about today's topic. Thank you.